I can see. Hi, Nura. You missed the first part of the lesson.
We're doing solving differential equations.
Stop throwing stuff, Parker.
General and particular.
Stop throwing stuff.
I'll let her watch this little piece.
Okay.
Or I can give you that little piece.
Action.
Okay, action. Where we left off right here. Shush. Okay.
Yes.
So we're going to solve this for y so that we can practice figuring out how to do that because that's going to happen a lot. They like natural logs. Like by they, I mean the AP people, right? They love natural logs and e's. Y'all haven't figured that out yet. So how do I get rid of a natural log?
E both sides.
E both sides. We're using the e verb thing. So this now becomes the exponent of e and this becomes the exponent of e. Okay, now. If I do e raised to the natural log of the absolute value of y, what do I get?
Absolute value.
Absolute value of y. I'm not actually going to have to write the absolute value symbol around that because, here's why. E raised to some number is never going to be negative. E raised to something is never going to be negative. E raised to a number, think about it.
E is a number.
E is a number. A number raised to another number is never
I
negative.
thought E was 2.7.
Uh-huh.
You're not saying that the
Negative one to the third
So
power.
even if the exponent is negative,
Am I wrong?
that's not a negative number. That's 1 over e squared.
But it's always
positive.
positive.
So e
Oh,
raised to
it's
any number in the whole wide world.
I was thinking like
Oh,
this.
why do you put pound symbol there, but not?
E to
No, that's
C
not
power.
Yeah, she's just playing tic-tac-toe now.
Oh.
E to any number in the whole wide world is always positive. So I don't need to have the absolute value symbol. In fact, we will never put the absolute value
No.
symbol
Why?
because it's not necessary.
Why
Okay.
did e and y become y?
Will I get counted off
I'm confused.
Why did e to the natural log of y become y?
Oh, e to the natural log of y.
Okay. Now, on this side, we can actually simplify that more. Here's why. Okay, let's review exponent stuff. If I gave you x squared times x cubed, what would that equal?
X
X to the fifth.
X to the fifth. Why? Because you did x to the 2 plus 3, right?
Yep.
So if it's written like this, can't I go backwards to here? Right? Written like this, we can go backwards. So isn't this the same thing as e to the negative 1 over x times e to the c?
But why would you do that?
Hold on, I'll show you why in just a second. I promise I'll get there. I'm just getting there very
Because
slow.
that's ln.
Okay, wait, no.
No.
Not Ellen. No, don't, no.
Now you LM.
But does everybody understand how I got here from here, right?
Yes.
Okay, but you told me earlier that e is just a number, right?
E is 2.7.
2.718 raised to a constant is just a number.
So it's C.
It's a constant.
Stop.
So
That's a different constant.
So E to C is C now?
So this is just a constant, so that can be replaced by c. So this is c e to the negative 1 over x.
we should play
So
rock,
why
paper,
is it
scissors.
negative 1 over x just negative ln of x?
Why?
Because I didn't do the antiderivative of it.
Oh. Never mind.
Your brain is like stuck in an antiderivative world. See?
Okay.
That's the answer, by the way.
Gosh.
Are none of the other ones the answer?
No.
On a free response, would we have to go all the way to that? If it
Yes.
asks for what y is?
They're going to ask you to solve for y most of the time.
C.
But would we be able to leave it as e to the negative 1
I'm just
over
gonna start
x
spelling
plus c?
things.
But that is
Y
y.
equals CALEB.
Okay, so I'm not saying that in a free response, having y equals e to the negative 1 over x plus c is incorrect. But what's going to happen once we get to the word problems associated with this, which is not going to happen before this test that we have on Friday. Okay? There are things that we are not going to get to that are AB topics that we're not going to get to because of this. Hey, let's have a few wellness days in the second quarter. So I'm going to have to throw some of that stuff in the second semester. So we will do word problems associated with differential equations, but not until then. When that happens, you'll understand why I have to get it to this form. But not yet. For now, just do what I'm asking you to do.
Does it
So
ever
could
spell
the-
CC?
What?
Does it ever spell CC?
No.
So
Okay.
could the answer be y equals
E to
But
the
C
whatever
times
over
E.
C.
That's just another
That's just a
constant.
constant.
Because it's a constant. The constant could be a
C
fraction.
to the negative 1.
Okay, but then you would just put C in front.
That
1
is-
over C is
Okay,
just a
like
different
you said, you can
constant.
do plus C or minus
Y
C. so-
equals C.
Right, but 1 over C,
I'm talking.
1 over C is just another constant, so you wouldn't write 1 over C, you would just write C.
But you
Okay.
could though, you could.
Caleb has a good point though.
What is
C
Caleb's point?
times E to the negative 1 over X, if C
another
is just a constant, C times E is just another constant.
No, because you'd have to do the exponent before you do multiplication.
I was just.
Please excuse my dear Aunt Sally, means exponents come first.
I did not think that.
Okay, back to this problem.
Is the square root of both x and y or just x?
That's just over X. So dy over dx equals the square root of X and then times y. Y is separate. Yeah, not the square root of X times Y, it's the square root of
Cross
X
divide.
times Y.
Cross multiply.
So I'm going to just multiply by the dx and divide by the y.
Cross multiply.
So, a new name for that, Parker.
Cross divide.
Cross dividend.
We need theorems named after us, okay.
Okay.
Okay, antiderivative of each side.
Yes.
Oh, yes. Antiderivative.
So, antiderivative of this side, natural log of the absolute value of
Can
y.
I skip that step and just go to E?
No. Do not skip that step. This would be a big point question on a free response. So they would have a point for separating the variables, a point for the antiderivative of each side, a point for the next step, a point for the next step. So here's where that plus C comes in. Okay, so antiderivative of this,
X to the 3 over 2.
so that becomes 2/3 x to the 3/2 plus C. And then I want you to solve this for y. So to get rid of the natural log, that's where you do the E thing. On the left, you get y equals. And on the right, this is E to the 2/3 x to the 3/2 times E to the C, which is just C, so the answer is
Oh, that's disgusting. That's so... Wait, why does
That looks really simple.
why does the plus C becomes times C?
because this is the same thing as E to the 2/3 x to the 3/2
This is on pre.
times E to the C
Ashley, you say that every day.
every day.
Definitely the day that.
Yeah, we've got way more stuff to confuse them later. Okay, and then E to the C is just a C.
Yeah, I don't care anymore.
I don't care. That's
Caleb, if you see the letter C with anything, it is just C. Except for when you have CE to sign
Except
the
Because
cross
CE
and the
can't
multiply.
be just C.
Except C.
Okay.
C's like the blob that just eats everything.
Okay, so the first step, of course, is to separate the variables. You cannot subtract 2x to separate them. That will not help you, okay? Because the subtraction sign on the same side of the dy dx isn't going to help you separate the variables. So instead, you want to factor, like Nicholas said back there. Factor out the 2x.
Oh,
dy over dx equals 2x times 1 plus y. And see how now I've kind of got the x separated from the y? So that I can then do that cross, whatever you, dividide, whatever he calls it over there.
dy, y dy, what's on the other side?
What?
dy, y, dy.
Y over dx, all I did was factor out a 2.
You don't have
never
to
mind.
factor it back
I was
in.
multiplying.
Yeah, you don't have to put it back in.
Okay, now I will give you a hint. If you have a coefficient in front of the variables, you're not going to want to move it with the y because that makes the antiderivative more difficult on the y side every time. So when I do this, I'm going to leave the 2 on this side. I'm not going to divide by the 2. So I'm going to have dy over 1 plus y equals 2x dx. So I divided by the 1 plus y and I multiplied by the dx.
Snare.
Okay, antiderivative of both sides.
Do we use this?
So you're gonna need to think about u substitution and if that's gonna matter.
It does.
In this case, if u is 1 plus y, then du is just dy, right? So it doesn't really affect that. Do I need to do it? If u
Oh, yeah, I
is
got it.
1 plus y, then du is simply dy.
No, it wasn't.
So this is just du over u, so that's natural log of the absolute value of 1 plus y. Equals. Antiderivative of 2x? X squared plus c. And to get rid of the natural log, we're gonna e both sides. So 1 plus y equals c e to the x squared. I'm skipping the step of writing that as e to the x squared times e to the c. And then subtract 1. Y equals c e to the x squared minus 1. Okay. Every single problem you do is not going to involve a natural log, just so you know. I only concentrated on those at the end because those tend to be the ones that confuse you the most. Okay, so don't be freaked out by the when you do one on the test and you don't get a natural log in the problem.
Can we
Okay.
do one that doesn't have it?
What happens then? No
Have we done
ease?
one without it?
Well, the very first example we didn't have e's in it, right?
Okay.
It didn't have e in
You're
it.
right.
I just didn't do a bunch of that one because that was the easier problem. Okay, now, what's the difference between a differential equation that's a general solution and the equation that's a particular solution? So, a general solution is going to have a c in the answer. A particular solution, it means we're gonna solve for the c and get one single answer with no c in it, okay? So the differential equation is this, and we know that 1, 3 is a point on the curve. So we're gonna start by separating the variables.
Didn't we already do this one?
I think we did.
We did.
Wasn't this the first one we did?
Yeah.
No, this is the second.
Second one we did? So we had, I forgot what it was already.
Final answer?
Yeah, y
Y
Y
equals,
equals c e to the negative 1 over x.
okay, so that's our general solution. So now we're gonna find the particular solution by plugging in this point for x and y and solving for c. So I get 3e to the c, e to the negative 1. So c is 3 divided by e to the negative 1, which is the same thing as 3e. Right, I moved the e to the negative 1 back to the top, made it a positive exponent. Okay, that's not my answer. That's just the value of c. So I need to go back and write the equation. Yeah.
You write it back.
What?
I,
So I divided by e to the negative 1.
and then you multiply it.
No, and then I just moved that from the bottom to the top to get rid of the negative exponent.
She wrote it backwards.
Okay.
But I went from here to here.
Okay, so I was like, what?
Oh, sorry.
Yeah, I did c over e and then multiplied it. Yeah. Because that's just.
What?
Okay, that's what I would have done too.
I'm confused. You did what? Oh, you made that into c over e and then multiplied by e.
Yeah, I
Gotcha,
was
gotcha,
like,
gotcha, gotcha.
wow.
Yeah,
So
the same.
c is 3e. Everybody has that part anyway, right? Okay, so my final equation though is not that. Nobody cares what c is. We care what the equation is. I mean, not to give c a complex, but so y equals
Nobody cares what
3e,
you
which
want.
is c, times e to the negative 1 over x. And guess what? They will not leave the answer like that. They're not gonna leave the answer with e written right next to itself. But what's the exponent on this e? 1. So that would be y equals 3e to the 1 minus 1 over x. Because you add exponents. Okay, now, how can I check my answer?
Take the derivative.
Take the derivative of it, because we know what the derivative's supposed to be, right? Okay, check our answer by taking the derivative. What is the derivative of this? I'm gonna come up here. What's the derivative of that? Well, so the derivative would be
It's 1 over x.
dy dx, or y prime, equals what? How do I take the derivative of something with an e in it? Oh my gosh.
Derivative of the exponent.
So that's negative,
Negative, I can't see.
what's the derivative of the exponent?
Negative.
So it's positive, actually.
Yes, x squared. So then, 1 over x squared, 1 over x squared, 1 over x squared.
Positive 1 over x squared
Yes, that.
Times.
times
Well, it's the ln of e, so it doesn't
3
matter.
e to the 1 minus 1 over x. Okay? Well, how does that prove that? It's supposed
We
to
got
be.
the ln both sides.
Nope.
No.
All I'm trying to do is to show that this is this.
We don't have even a y in our problem.
Because we know that.
But don't we know that y is equal to 3e to the 1 over 3e to the 1 minus 1 over
Yes,
x?
so
Oh.
you substitute y back in.
So
Oh my
substitute the
God.
y back in and I get dy dx equals y over x squared. Back to where I started.
This is hopeless. We don't even have a y.
We don't even have a y. Yeah, we do. Okay, so you can always check your answer, at least when they're not so bad. Except when you guys don't know how to take the derivative of something, and then that's a problem.
I took the derivative.
We just got done
Okay.
taking a quiz on the anti-derivative.
I know. Oh God. Okay. So let's. Find the particular solution.
Chumas to do this on.
Sure.
Oh, that's not what I meant.
What happened?
So I have to do this on my own? Yes, of course you should be able to do this on your own.
We already did it.
Did we? No, we
No,
didn't.
we didn't.
We didn't.
Oh, there's a. You're right,
Oh no, my y has something on
Oh no, that means you have to do U substitution.
it. No.
What?
But luckily, there's the fancy.
But what if I wanna just take the 2 out and then get 1/2?
Oh, okay, that'll work.
That was genius. That just was genius.
I'm not gonna do it that way, I'll do it this way, cause this is pretty easy. So I do the U substitution, I end up with this being 1/2 antiderivative of du over u, so it's 1/2 natural log of 2y plus 1 equals 1/2 x squared plus c. Okay, now, before you e both sides to get rid of the natural log, you have to get rid of the 1/2. You cannot have a number in front and e both sides. So you have a choice. You can either make this a square root, or you can just multiply everything times 2. I think I'm always gonna choose. I really think I'm gonna do the multiply by 2 thing. So then that would give me natural log of 2y plus 1 equals x squared plus c. It's just a different c now, it doesn't matter. No, just c. It's just twice as big as it was before. Doesn't matter. Now I'm gonna get rid of the natural log by e-ing both sides. So I have 2y plus 1 equals c e to the x squared. So y equals, this is gonna, c e to the x squared minus 1, all divided by 2? Or you could write c to the x squared minus 1/2. Because the c would just be a different number now. Sorry, Ashley's making this face at me. Okay, it's not gonna matter how you write it. Honestly, like if you wrote like this, or if you wrote c over 2 e to the x squared minus 1/2, or however you wrote it, it's not gonna matter. That's why finding the value of c is not what they're looking for. Because I could have stopped and solved for c way over
That's
here.
what I was thinking.
Right? Like I could have solved for c back here and put it in and then solved my equation for y. So that's why they don't really care what the value of c is, because there are different values of c depending on when we stopped, right? So, right.
It's different based on where you do.
Where you do it, you're gonna get different values of c. Now your final equation will not be different. I could stop and do it, and we can do it several different times. But I'm gonna start right here and find the answer with the 0, 3 as my point. So I have 3 equals c e to the 0 minus 1 divided by 2, which gives me 6 equals c minus 1, so c must be 7. So going right back to the place where I stopped and solved for c, I would put the 7 here. That gives me that my equation would be y equals 7e to the x squared minus 1 all over 2. Because I went from here and substituted in that c value. Now I want to show you, you don't have to write this down, I just want to show you what happens if you do it differently. If I had stopped right here and solved for c, if I had come up here and solved for c, I would have had 1/2 natural log of, I'm substituting in y equals 3, so that would give me 7. So I don't need the absolute value because 7 is positive. Equals 1/2 times 0 squared, so that's 0, plus c. So c is 1/2 natural log of 7. Are we okay with that, right here? Because that's 0. So here I go right back to where I was and I say, well, that means my equation is 1/2 natural log of 2y plus 1 equals 1/2 x squared plus 1/2 natural log of 7. Haven't solved it for y yet, but I multiply everything times 2. And now I'm going to e both sides. So I get 2y plus 1 equals, now I have e to the x squared plus natural log of 7, like that. We're okay at e both sides? Everybody with me? Okay, now I'm going to split this up. And I'm going to make that e to the x squared times e to the natural log of 7. E to the natural log of 7 is just 7, right? So now this side equals 7e to the x squared, and that's equal to 2y plus 1. Subtract the 1 and divide by 2, and we're right back where we were over there. It doesn't matter where you stop and solve for c. I tend to wait until I've solved the equation and then solve for c. A lot of times when I'm looking at the answer key for the AP exam, they'll stop and solve for c here. Doesn't matter where you do it, you're going to get the same answer. Yep.
So wouldn't you have gotten something different if you put the 2 only under the minus 1? 'Cause
Okay,
it would
so
be-
let me go back here. Okay, so if I'd said, oh, okay, well this would be the same thing as 2y equals c e to the x squared minus 1. I'm going to divide by 2, but that divided by 2 doesn't matter because it's just another constant, so I have that now, right? Okay, I substitute in the 0 and the 3, and I get 3 equals c e to the 0 minus 1/2. So if I add, that would be 7/2 equals c. You okay with that? 3 plus 1/2 is 7/2. Okay, so now my equation is using this. Y equals 7/2 e to the x squared minus 1/2. If I wrote it as one fraction, it would be 7e to the x squared minus 1 all over 2. So my c value is different. But when I go back to where I stopped and solved for c, I'll get the same equation. So I just did the same exact problem 3 different ways. General solution was the same no matter what. Specific solution was the same no matter what. Just a matter of where I stopped and solved for C. Okay. Okay. New problem.
Wow.
That's a lot of those.
Really, it's only 3.
I think that can fit into.
4. X, a Y, a D, and an E. That's all.
Well, those are
then we'll add it
They
up.
occur
Surely
multiple
math
times.
is more.
And then I
Number.
bunched them together with different, yeah. Okay.
There should never be an X, Y, D, and X next to each other.
And X, Y, D, X all in the same problem?
This is the problem they should be in here for. can
I
just feel
am
it.
recording it. We can show it to
Okay,
them.
you can show it to your friends later.
Yeah.
If it makes you feel smarter, because you're gonna be like, this isn't that hard.
Also show them the one where it has 3 different answers.
Oh, yeah.
3 different ways to solve for one answer.
They look different.
We need one day where we just write a whole bunch of math on one board and be like,
Don't
yes.
worry, we are gonna have a day when there's a problem that we do, like, involves a lot of the math you've ever learned in your life, yes.
You should
Like, all
one
math.
day like have us
Yeah.
come in during sync period.
I can't
and
remember
just
the
quickly,
exact
like,
problem, but one year,
solve
like,
this
I had
giant
solved a problem that
equation.
took 2 boards, and my class went, like, that's literally everything we've ever learned in math. It had division in it had trig in it, it had everything I've ever learned.
Just
So,
have to use-
And then we found the tangent line of
Yeah.
it all.
okay,
It's true.
so,
You need to use the antecedent.
here we go.
No.
Now, all of the problems that we've done so far, we have 0 on the right side, right?
Right.
We had the dy and the dx separated. And we typically had cross multiplied to get them separated or done some fancy word that Parker keeps saying, right? The only difference here is that somebody else has already like done the cross multiplication and then they thought they would be tricky by putting them on the same side of the equal sign. Guess what I'm gonna do? I'm gonna take this and I'm gonna move it back to the other side of the equal sign.
Yeah.
Okay.
Yeah, sure.
Dumb people, they just tried to trick me
Yeah.
by putting them together.
Who made this
So
problem?
silly.
Washington students that made the problem?
I didn't make the problem.
Okay, fair enough. Was it an AP problem?
I don't make this crap up. No, I'm just kidding. Sometimes I do, but no, this is not an AP question. I just got it out of a book somewhere.
That's what we need.
Could this possibly be an AP question?
It's fine.
Could be.
Okay.
So
Okay.
if I memorize this, I could get 3 points. Is that what you're saying?
You mean this one question?
This is
I
one
don't
question.
think so. I
He
don't
comes into the
think
exam
you're gonna get it.
only knowing
I'm
that.
gonna memorize every question you've ever worked. Okay, so I still have to get the variables separated, but now it's a little easier, right? So if my dx is on this side, I want everything with an x on this side. So I'm gonna divide by the y to get it over there, right? So I'm gonna move that over to here.
That's not. Oh, wait.
Why did it only go to that?
Wait a
I
second.
divided both sides by y. Do you want me to write it on both sides?
No, why did it not go to
Because
the
she's gonna divide the negative
I'm gonna
e
divide
over.
the x
Okay.
stuff to the other side. So now, this has an x in it, so I need to move it to this side, so I'm gonna divide by that.
Oh,
So now I have x over negative e to the negative x squared dx
You just put that to the
equals
top.
y squared minus 1 over y dy. And I'm gonna have to do some simplifying before I can do an antiderivative here.
Can you move that e to the top?
Yes. First thing is we don't know any antiderivatives with e's in the bottom of the fraction. We only know e in the top. So I'm gonna move that to the top. And I'm gonna make this negative x e to the x squared dx. And what am I gonna do with something that looks like this on the right side? I'm gonna divide it up, right? So y squared over y is y minus 1 over y dy. And now you're ready to take the antiderivative of each side. Tell you what, you guys do the left side and I'll do the right side.
Oh, you're so generous.
You're welcome. Oops. I'm gonna do it correctly.
Can we switch sides?
Is that a power?
This? We don't have a backwards product rule. Q substitution.
Okay, good.
Can't have a product rule, we don't know those.
Great.
Will we?
Eventually, second semester.
I forget we're not even in the second semester.
We're not ready for that
We've
yet.
done so much.
Oh my
already.
Um,
I got the error, but I forgot.
what?
I got the error.
Good. Now put the U back in. Do the antiderivative of E to the U. I'll put it over here. So that's negative 1/2 e to the U is x squared plus c. We're not going to solve this for y because we can't.
Good.
This is not a function.
I don't want such.
However, we still don't have the particular solution, because we cannot have a c in our answer. So we're gonna stop right here and solve for c.
Can we at least make it prettier?
What would you like me to do to make it prettier? Multiply by 2,
Oh yeah, I was about to say that.
so that we don't have fractions? Sure. But people probably already started solving for c, so let's just do that first.
I didn't
So,
know that's all.
x is 0 and y is 1. So if y is 1, I get 1/2. And then the natural log of 1 is 0, so that part goes away. Equals, see, x is 0, so negative 1/2. And then e to the 0 is 1 plus c, so c is 1.
That was not like.
Stupid.
What?
I thought that was gonna be a lot for you.
I know, it looks like it's gonna be hard. So then I'm gonna go right back to where I was and substitute in the c value. So 1/2 y squared minus natural log of the absolute value of y equals negative 1/2 e to the x squared plus 1.
It's amazing what's the answer on this curriculum.
And that's the answer.
And that is the answer.
But wait.
That is an answer.
That is
Oh my God.
I could multiply everything times 2 if I didn't wanna have fractions in it, but can't solve for y. Cause it's not a function, so. Okay.
I did all on one page.
What? Yeah, you can stop the video.
That was
Okay.
the last.
Fine, or,
Last one. I mean, didn't that need